world, and welcome back to the channel. Most people learn Java. On this channel we build with it, so I'd like to welcome you back to another lesson, another great lesson that I want us to do or have on bubble sort algorithm in Java. Now, bubble sort works by comparing what we call successive pairs of elements, then swapping them if they are not in ascending order from the smallest to the largest. Take the case of the array that we have up here. Our array is disorganized, so the smallest element would be 1, followed by 2, followed by 3, all the way to the biggest element being 6. How it works, because we've talked about comparing successive pairs, it first picks the two elements, the first two elements that are in the array. So that is the 4 and the 2. The comparison is the element on the left bigger than the element on the right? If it is bigger than the one on the right, then the swapping has to happen. Now, something interesting about bubble sort technique is that if two elements have the same values, then the resulting data will have their order preserved. So if we were to have, say, a 2 and another 2 somewhere, so that order is going to be preserved. Now, small elements, when it comes to bubble sort, always bubble to the top of the array as we continue iterating through the data structure. Another very important point I want you to note is that bubble sort works best for small data sets. So like the case of what we have here. So someone who is just trying to learn how the sorting algorithms work for learning purposes only is best suited to use bubble sort. But in larger data sets probably would not be the best one to go with. First things first, what we always do is the same when it comes to all arrays. We're going to create a for loop, in this case just a normal for loop that we're going to use to iterate through our array. So we always have the loop counter variable, and since we are talking about an array, the very first index is always 0. From there we're going to have the not the comparison, sorry, but the condition, the boolean condition here. So as long as I is less than our array.length, yeah, and then at the very end we're going to update our loop counter variable. However, here's what I would like you to think about. Actually, it would be easier if we were to get the error and then we see how we solve the error. So here's our loop. When it comes to comparing the successive pairs of elements, different developers normally implement this part differently. So in my case here, this is how I would go about it. The comparison, we can always use an if. We are checking whether the element on the left is bigger than the element on the right. So how we indicate that is nums, which is our array, at index I. So quote unquote, that is the element on the left. So we're checking whether it is greater than the element on the right. So to denote the element on the right, we're going to have I plus 1 there. So if the element on the left is greater than the element on the right, at this point we swap. For us to swap, I would suggest we create a variable that we could call temp. So just hold one value temporarily away from the array so that we can have at least a way of adding an element to that particular slot. So in this case we're saying the element on the left is what we're going to place, sorry, nums. The element on the left is what we're going to place aside just temporarily, so that now we are sure that that particular slot, now in this case the slot is index 0. So index 0 is currently free, meaning we can add any element that we want there. So we're going to take that empty slot, we're going to add to it the element now that was on the right, which was I plus 1. When we do that, sorry, keep forgetting the M there. When we do that, it means now index 1 is free. Free means we can now take that particular index I plus 1, and then we can add to it the temporary value that we had held on the side there. That is the swapping. So at this point is swap. So this is compare successive pairs of elements. That is what we are doing at this point. So if the element on the left is bigger than the element on the right, we simply swap them. So up to that point, I would think we are okay. So this is what I want us to do, just basically test. So print out the array, just to be sure of what we have. So I would suggest we use for each loop, it's going to be faster and cleaner in this case. So we create a variable that is the same type as our array, then full colon, and then on the other end we add our array. Then at this point we're just going to come and print out this j, but okay, there's no harm in using a print line instead of having everything on one line. We are not yet through. I just want us to understand exactly what is happening. Currently the 4 and the 2 we expect are going to be swapped, but no other element is going to be swapped. So when we run this, we're going to get the 4 and the 2 being swapped. Actually we get an error. I was expecting the error, but I didn't expect it to come this soon. So index 6 out of bounds for a length of 6. If you count the elements that we have in our array, these are 6 elements. 6 elements means the index or the indexes are supposed to be running from 0 all the way to 5. Meaning at some point somewhere we are looking at element at index 6 which does not exist. So I would say it is this point here. So through all that comparison, when we get to the 5 here, this is what is happening. This is picking nums at index 5, which is where the 5 is, and then we are comparing it to nums at index 6, yet we don't have index 6 existing. I would like to propose something. This point here, since we are looping through the entire array, I would like to suggest that we stop just before the last element there. Two things. Number one, we avoid the array index out of bounds exception that we're getting from here. Number two, we don't actually have to loop through all the way to the last element because we expect the biggest value is going to be pushed and occupy that last slot. So currently we should be okay in terms of the error. We are not supposed to get that error, but our array is far from sorted. So 2, 1, 4, 3, 5, 6. We did manage to push the biggest element to the far end of the array, but we are not yet there. What happened is our loop, the for loop, has gone through the array once, but we need a way to make sure that the loop keeps going through the array over and over and over again until the entire array is sorted. So one thing that we can do is we can create a Boolean variable at this point, and maybe I can call it need next pass. So do we need to go through the array again? So I'm going to initialize this variable to true. Then I'm going to create a while loop up here, and then the loop counter variable in this case is going to be need next pass there. So this loop, I would expect, is going to end right there, meaning our for loop is entirely inside the while loop. So the only way for the while loop to run is if the only way for the for loop to run is if this condition remains to be true. Here's what we have ascertained. When the for loop went through the array the first time or once, the array was not fully sorted. So we can come down here after the swapping, we can take that need next pass variable, and then we can assign a value of true to it. Why? Because we are sure we need to go through the array again and again and again. So as long as this variable keeps having a value of true, the while loop keeps repeating. Now, in the event that we have gone through the array fully and everything is done, everything is okay, that is the point where we would need to negate that particular variable. So need next pass, and then we just come here and make it false. But this is at the tail end, far end, assuming everything, or rather assuming we have gone through the entire array, we have swapped, or rather our algorithm has swapped all the elements that need to be swapped. Currently, we should be okay. It should have sorted our entire array, so 1 all the way to 6. Now, different developers, just to repeat again, implement the bubble sort algorithm differently. So this is just one technique. The challenge I would like to throw to you is simple. Number one, what I've done in this example is I've had everything running within the constructor, but it would be easier to make sure that the algorithm is in a method on its own. So the first challenge I would like to throw to you is make sure that the entire algorithm stands out from the constructor. It's in a method on its own. Challenge number 2, try something different in terms of the array. Try a bigger array. Try an array with probably bigger numbers, and just test how the bubble sort algorithm works. Remember, this is for learning purposes only. In future, I do expect that we're going to create bigger, or rather we're going to have bigger data sets that we're going to be testing with. So for now, that is where we come to the conclusion of our video on bubble sorts technique, bubble sort algorithm in Java. Thank you for watching. Please remember, subscribe, like the video, and share to as many people as possible. And let's meet in the next one.